So picking back up with these ideas, remember force, that's given by Coulomb's law. F equals K QQ over R squared, or K QQ over D squared. Fields. Fields are a force per charge, and the field we'll find, well, we're about to calculate an equation to calculate the field. But we use our imaginary test charge to figure out what the field is. And then soon we'll see potential. And potential is an energy per charge. It's going to be our definition for our potential. So we can combine Coulomb's law and the definition of the electric field to figure out how we actually calculate the magnitude of the electric field. The electric field is defined as F over Q. But we know that F is KQQ over D squared. And we divide that by Q. These two Q's cancel out, and I'm just left with KQ over D squared. And that is our equation for the electric field. So it's going to be KQ over D squared. You won't have to calculate the electric field, but you will have to know how the electric field varies with different variables. So for example, if Q goes up, E goes up by the same amount. And if Q goes down, or excuse me, if D goes up by a little bit, E goes up by a lot, because I have this inverse square relationship between E and D. Okay, sorry about that. So there are two main points that we want to walk away with fields. First, charges produce fields, or even a single charge can produce a field. If I have a single charge here, it will produce a field if it's positive. I can figure out where that field is by imagining a positive test charge right here and asking myself, what is the direction that that positive test charge feels? It will feel a force in that direction, and so that is the direction of my electric field. Okay, so charges produce fields, and a force acts on a charge in an electric field. So for example, if I have another charge right here, it will experience a force because it lies in the electric field of this other charge. And so if this happens to be a positive charge, it will feel a force in that direction, and that force will be equal to Q times E. Right. We'll come back to electric potential energy.